Hello and welcome to another video. In this video we're going to be working on the two keys keyboard, and in this one there's a character A on a notepad and you can perform one of two operations. You can either copy all the characters or you can paste all the characters you copied, and you can keep pasting. Given n, return the minimum number of operations to get the character A, exactly n times. So we have a character A, so we want to get 3 of them for the first example, so we're just going to do a copy. So I can literally show this, right? So we copy, and then we paste and paste. That's 3 operations. And then for the next one, we already have a character, so we don't need to do anything. So for this one, there's 2 ways to do it. One is easy to come up with, and one is difficult, kind of like yesterday, I think. And so let's briefly talk about the easy one that, if you had an interview, this is the one I would go with. So essentially, we have 2 options. Like, we have a letter. And we have 2 options. We can either copy it, or we can paste. But we can't paste unless we have something copied. So there's a couple of ways to write this, but basically because we have 2 options, this is like a very simple DP function, where all we have to keep track of, if you think about it, is how many characters we have left to write. And so we can figure out how many characters we have written and how many characters we have left to write in one variable, right? Like if n is 5, and we just keep track of like how many characters we've written, let's say. Like we written 3, that means we have 2 left. So this is just one variable. And then the other variable, you can do one of 2 ways. You can either have a variable writing how many characters you have copied, like on your current copy, or you could do this in a for loop. And so let's briefly talk about kind of how that would go. So essentially, let's say we're trying to get like 10 characters or something. So we're trying to get 10. And we start with 1. And basically what we can do is we can say like, well, to get to 10, we're going to have a sequence of events that's going to be like copy some number of pastes, right? So paste times x, and then another copy, some number of pastes, and so on. You're never going to want to copy once you're done, right? So it's always going to be copy with some number of pastes. So what we can do is we can say like, okay, well, in the beginning, we have 1 character. Let's just for loop, try to copy that and recurse every single time. So we'll have like 1, and then we'll try to do a copy with 1 paste to get to 2. We'll try to do a copy with 2 pastes to get to 3, copy with 3 pastes, and so on and so on and so on, up until you get to n. So you could have a for loop where you just try to copy your character or however many number you have, and you just keep pasting until you reach over n. And then like the best one of those branches is the result. So you'll go from like 1 to 2 to 3 to so on. And let's say we currently have like 3 characters. So we're going to do a copy, and then we're going to try to like paste once, which will give us 6, paste twice, which will give us 9, 12, and so on. And then if n is whatever, we're basically just going to have a for loop. For every single number, we're going to have a for loop. And so that DP solution would be it would be n squared, because we're going to have like our number of characters we currently have can be anywhere from 1 to n, and then the number of characters we're copying is going to be that same number, right? So it's going to be n squared time and O of n space. And the even simpler DP solution, if that one's a little bit confusing, is you can use 2 variables for state. So we can just have like the characters we have and the characters we have copied. So when we make a copy, like let's say we have 3 characters, if we make a copy, then that means we have 3 characters copied. And we can paste if we have something copied. We're allowed to do that. And then when we copy, we will not paste and replace this copied variable. So you kind of have 2 choices. You can paste if you have something copied, so make sure you have some number here. And if you want to copy, you can always copy, I believe. Yeah, I would think so. You can always copy. And then your base case is something like the number of characters is 0, so you just return 0. And then if you pasted too many, so if your number of characters is greater than n, then you just return like infinity or something, and you just maximize that. So it's a pretty basic DP solution. And I can briefly show my Python one for that. But there's another one, and like I said, this is the trickier one, and this one involves the fact that, like I said, we're kind of doing a copy and then some number of pastes, and then a copy and then some number of pastes, and so on and so on and so on. So the idea is we can just figure out, like, okay, for all these blocks of copy and paste, what we can't do is we can't go over n. So is there some efficiently way to figure out, like, when we want to copy and when we want to paste? So let's say there was an example that I saw that was like, if we do a copy and 5 pastes. So we start with 1, we do a copy and 5 pastes. So we go from 1 to 6, right? We're basically saying, okay, we're going to have an A. We are going to copy it. And then we're going to paste it 5 times. There we go. And we're just going to paste, and that'll give us, well, you know, let's say we're trying to get this. Well, is there a way to do this faster? And there is, right? So what we can do instead is, so this is 6 operations to go from 1 to 6. And the faster way is you do a copy, and then you do a, you're never going to want to do 2 copies in a row, right? Because you'll just copy the same thing. So you're going to want to do a copy, and then you do a paste. Then we'll have this. Then we'll do a copy, and then we'll do a paste and a paste. So let's look what that will look like. So we do a copy, we do a paste, we do a copy, and 2 pastes. And so this is the idea. So we're going to want to copy as much as possible to double or triple our stuff. Because anytime we do a copy and a paste, right, like if we have a 1, if we copy and paste, that gives us, you know, let's say we start out with X number. If we do a copy and paste and then a paste, or let's say we do this, right? We do copy, paste, paste, paste. That will give us 4x of what we have, right? So copy, paste, 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 whatever x is, right? But if we do copy, paste instead, then we will get more, right? So we do copy, paste, Actually, I think this will give us the same. So this will give us the same, but if we keep pasting, that will give us more, right? So if we had something like this. So basically the idea is you're always going to want to ideally, like, you're going to want to copy as much as you can and paste as much as you can, and you're not going to want to, like, have some small number that you repeat. So let's look at, like, another simple example. Let's say n's like 24. Well, what we can do is we can just say, like, okay, let's just take the first letter and paste it a bunch of times, right? And we can just keep doing this. And that's going to be a copy and 23 pastes. But instead, what we're going to want to do is we're going to want to copy paste as much as we can, but we want to make sure when we copy paste, we don't go to some number that isn't a factor of the number you're going to. Because, like, imagine we get rid of these copy paste. Let's say we're just trying to go from 1 to 24. And basically our option is either put another of whatever we have or double our number, I guess, or something like that. So you're never going to want to go from like a 1 to like a 5, because then you can't go from a 5 to a 24. So when you increase your number, you have to make sure that whatever number you're going to is still a multiple of 24. And that's kind of the idea behind the second solution. So the idea behind the second solution is we are going to go from 1 to multiples or factors of n. And we're always going to make sure that our number stays a factor of n. And the way to do that is we just basically take all the factors of n, and we're going to keep multiplying our number by that. So let's look at that solution. So let's say we have this 24. So what are the factors of 24? So it's 8 and 3, which is 2, 2, 2, and 3. So this is actually going to be the optimal solution, because we're gonna use these factors. So the idea will be is we'll have an a, and then we'll do a copy. So how do you multiply by 2? You do a copy and a paste, right? How do you multiply by 2? Do a copy and paste. How do you multiply by 3? You do a copy and you paste twice. So the number of operations for each factor. So if we have factors, if we multiply a number by 3, we already have 1 out of the 3, right? So we're going to have to basically paste. We're going to have to paste factors minus 1 times, but also we need a copy. So the number of operations will just be the sum of all the factors of the number. So basically all you need to do is just get all the factors of a number, and that's going to give you the fastest thing. And you don't want to do something like you want to get the prime factors, because this is the same thing, where instead of doing this, what if we just did this? Like, this is possible, right? Like, we can just take our number and we could say, like, let's copy and paste 7 times. Well, the factors of a number, right? This is just like math. If we have a times b, that equals c. A plus b will always be less than or equal to c, right? Assuming these are integers. So like if c is 8 here and this is 2 times 3, you're always going to want to multiply over add. Sometimes it'll be the same, right? So hopefully that makes sense. Like 1 times 1. I guess 1 wouldn't be that, but that's about it, right? So the only assuming a is bigger than 2, or bigger or equal to 2, and b is bigger or equal to 2, then this is always true. If they're 1, obviously won't be. So that's kind of the idea. So what we can do is, let's go back to our example. So 24 will be 2 times 2 times 2 times 3. And so what is this operation? So like I said, multiply by 2 is just a copy paste. Then multiply by 2 again is just a copy paste. Then a copy paste. Then a copy and paste twice. Because multiplying by 3, we already have 1. We need 2 more. So let's look what that looks like with the actual a character. Oops. Okay, so let's say we have our a character. Just write an a. Let's make it bigger. Okay, so we're going to copy paste. Then we're going to copy paste. Then we're going to copy paste. And then we're going to copy the whole thing and paste twice. And that gives us 24. So that's kind of the idea. And like I said, this one's harder to come up with. The DP is simpler. Is we basically always just want to get the prime factors, because anytime you have something that can be divided further down, that will give you less operations. So here the number of operations is 2 plus 2 plus 2 plus 3. Where if we had any other factor, like I said, like 15 is always going to be more than just 5 times 3. So that's why you're going to want to break it down to the smallest factors possible. So the idea basically now we can say is like, let's just get the prime factors of the number. And so to get the prime factors of a number is pretty simple. All we have to do, there's a bunch of ways to do it, but we can just do it in linear time. Yeah. You can also do it in square root linear time, actually. Yeah. Yeah, I guess we can do that, because the idea here is we should be able to do it in square root linear time, because the idea here is if a number has factors, basically if a number has factors, it's going to have factors a and b, right? So if let's say a number is a perfect square, that means that both of these are the square root of that number, right? Or that's like one of the combinations. So if a number is a perfect square, there's 2 numbers. And I think even if a number isn't a perfect square, there's 2 numbers that like the number times itself is going to equal your number, right? So even if you have a number like 24, some number times itself will equal that, right? Because you can get the square root of 24, it just won't be a whole number. So the idea here is we can always get one of those numbers, and then we should be able to get the other one. And the way it works is basically like, so the square root of 24 is going to be like 4 point something, but 24 is 2 times 12. So what we can do is we can get all the factors that are less than or equal to the square root, and then there will only be one factor that's bigger, basically. Hopefully that makes sense. But basically, if you have 2 factors that are equal to the square root, once you increase one, you'll decrease the other. So like if this is the square root of 24 and this is the square root of 24, because they're factors, if you increase this one, you will decrease this one. So we can do the square root, or we could do a linear time one. Let's try the square root and see how it goes. But I think that should work, because I did have a video on prime factorization square root. So it's going to be a slightly more complicated solution, but I think it should still work. Okay, so let's do that. Okay, so what we need to do is we need to get the square root of the number, and the way the prime factorization is going to work is if we get to a number that's bigger than the square root of a number, we just have to check what n is, and I'll kind of show that. So we're going to have result. We're going to have the square root. And we can just take math square root of n and round it up because we want to check all those. That'll be fine. And then we want to have a factor, and we want to start at 2 because we don't want to use 1. We want to basically bring n down to 1. And so then we can say while factor is less than or equal to n, while n mod factor equals 0, which means this is actually a factor, result plus equals factor, and divide n by factor. And so if we do have the case here where one of the factors is bigger than the square root of n, like for example, let's take a number like 14, it's going to be 2 times 7. This is where I was saying you can only have one factor that's bigger than the square root, because if you had 2, right, like let's say for 36, the square root of 6, you can't have 2 factors that are bigger than the square root, because then those factors together would be bigger. So you're basically going to have either one factor that's bigger than the square root or none, because like for 36 you can have 2, 3, 2, 3, which are all smaller than the square root, but for 14 you would have a number that's bigger. So all we have to do is just check if n is, so if there is a factor that's bigger than the square root, n will be greater than 1 here. And if that's the case, then we want to return result plus n, because that's the case of like the 2 times 7. So basically what would happen is square root of 14 is like 3 something. So we'd round this up to 4, and then we check for a factor of 2, which is there, check for a factor of 3, which is not, we check for a factor of 4, which is not, and then n will be 7. So then it's 2 times 7. So we need this one as well. So hopefully that makes sense. If you don't want to do the square root, you don't have to do the square root. You can just say, you can just do the same thing without the square root, and I'll kind of show that really quick as well. So this should work, and this is just result. Let's see. Oh, we also need to actually keep incrementing our factor. So the idea is if something's a factor, keep dividing it until it's no longer a factor. Okay, so this would work, and this is like the best, but you don't need to use, actually, do I even use the root? Oh, I don't even use the root here. So I think this needs to be root. But you could see either one works. Hopefully that makes sense now why I did this. So if this is confusing, you can just say while factor is less than n, and then just return result, and that would work as well. Either one's fine, but this should be theoretically faster because it should be square root of n. So this should be square root of n. And then also for each one of those, you're basically dividing it by a factor a bunch. And so if you're dividing by a factor a bunch, you can have square root of n factors, and each one of those is like log square root of n, something like that. Because the prime factorization, or like taking a number and dividing it by a factor a bunch, like think about if you just have like some big multiple of 2, and you keep dividing by 2, that's log n. So this is log square root of n based on the factor. And the factor is going to keep increasing, so this is almost negligible, but it's still there. Okay, and then space is O of 1. We didn't really use anything. So hopefully this is helpful. Like I said, the DP one should be more straightforward. This one's a little bit trickier. But yeah, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.